Good evening, ma'am.
Good evening, Abhika. Good evening, Prithviraj.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Very good evening. Queenie, your voice is cracking, dear. Very less number of students are there today. Please put on your cameras.
Good evening, ma'am.
Good evening, Devesh. Turn on your screens, please. Shall we begin now? Okay, let's start now. Everyone, please put on your cameras. All of you.
Good evening, ma'am.
Good evening. Oh, so let's begin with the next chapter, motion and time, right? How can you describe motion?
Ma'am, like, can we start any chemistry or chapter?
Any chemistry chapter. Okay, you tell me which one.
Chemical and physical change.
Chemical and physical changes isn't in class grade 7, I guess. This is class 6 chapter.
Ma'am, it is. Ma'am, in
Class
there.
Okay.
think it is there, ma'am.
Ma'am, but can we do motion and time?
Ma'am,
Yes,
can we do
listen
physics?
to
Yes,
me.
ma'am. Can we do motion and time?
Yeah, after we finish motion and time, definitely I'll take any chemistry chapter. Okay.
Okay.
So how can you describe motion? Rishit or Sritij?
Ma'am, motion is like the movement of an object or any organism or anything that moves.
That moves or we can say changes its position.
Yes, sir.
Moving from one place to another.
Yeah, or
Ma'am, can I tell?
with respect to time. Okay, yeah, Divesh.
Ma'am, like when an object moves from place to place from time to time, it's in motion.
Yes, Charvik, please say.
Ma'am, it's like the movement of any organism or any object.
Charvik, your voice is not clear and it's low as well. So please speak clear and loud. Movement of any object or organism. Okay, great. Fine, all the answers are correct as we have learned this in class 6 as well. That when an object keeps on changing its position with respect to time, this is known as motion. And now there are several types of motion. Means not necessarily everything will follow the straight path. Some may take a curve, some may take a complete circular path, some may follow the stairs, zigzag path, etc. So, what are the types of motion?
Ma'am, circular motion, rotatory
Ma'am,
motion.
uniform and non-uniform motion.
motion, periodic motion, oscillatory motion.
Oscillation.
Ma'am, uniform and non-uniform
Rectilinear.
motion.
Okay.
Ma'am, linear motion, non-linear motion.
Ma'am, circular and periodic motion.
Okay, great.
Ma'am, rotation.
Ma'am,
Oscillation.
rotational motion and auxiliary motion.
Very good. Very good. Very good. Let me just note it down. Hold on.
Ma'am, random motion.
Random motion is also the correct answer. Great.
Ma'am, your voice is very low.
Wait,
And
hold on.
translational motion.
So first of all, wait just a second, please. Just a second, no, there is some issue with my computer.
Ma'am, we cannot hear you.
Wait, dear, wait. If I'm not able to write these, give me a minute, let me rectify what's happening.
Ma'am, your voice is very low.
Yeah, actually my pen tab stopped working. Okay. So basically, motion of an object is defined when an object keeps on changing its position with respect to time. It is said to be moving or moving. And motion can be of different types, right? First is linear or straight, which is also known as rectilinear motion. Whenever an object travels straight in a straight line path, we say it is a rectilinear motion. Sometimes the object travels along a circular path, that is circular, and not properly circular. If it just takes, some light curve or deep curve, doesn't matter. That is called a curvilinear
Ma'am,
path.
your voice is breaking.
Is my voice still breaking?
No, it's not.
Hmm.
Ma'am, but like, can you be a little loud?
Okay. Next is periodic, the motion in which motion repeats itself in the regular intervals of time. Okay, now your task is to state examples for each type of motion.
Okay, ma'am.
Hmm.
Ma'am,
Ma'am,
so
linear straight means march past, soldiers doing march past.
Okay.
Circular can be a man riding a cycle.
A man riding in a athletic race.
Okay.
ma'am, so curvilinear, a man riding a car in a curvy road.
Great.
Ma'am, the motion of
Ma'am,
an arrow.
ma'am,
Ma'am,
Motion of a snake.
evolution of the
Motion of
earth
a
around
snake.
the sun.
ma'am, even clocks are circular one.
Great.
Clocks are periodic motion also.
Ma'am, periodic
Ma'am,
motion can be
pendulum.
like a person moving in a swing is periodic motion.
Okay. Now listen, please. March past person riding a bicycle or the race athletic is are all examples of rectilinear motion, right? Now state for circular only. Circular.
Ma'am,
A
ma'am,
clock.
Repeat
ma'am, the Earth's
is
revolution
circular.
around the sun.
Rotation of,
Ma'am, the revolution of Earth around the sun.
very good. Revolution of Earth around the sun. More.
Ma'am, also
Ma'am,
revolution
wheel of a
of moon
bicycle.
around
Ma'am,
the Earth.
wheel of a bicycle when we ride.
Okay, great. Wheel of bicycle circular.
Ma'am, fan.
Sun also moves.
Ma'am, I think he said fan.
Yes, sir.
Not getting, sorry.
Ma'am,
Ma'am,
fan.
Fan. Okay, fan. Fine. We have 4 examples. Now state for curvilinear path. One of you said motion of
A
snail.
man
So
riding
we can say
a man.
motion of a snail also, isn't it?
yes, ma'am.
More examples for curvilinear.
Ma'am, a man riding in a curvy road.
Man riding
A man riding a car in a curvy road.
in a corridor. We can
Ma'am,
say
like a roller coaster moving on a track, it will be curvy, right?
roller coaster moving on a track. Okay, that can be. And the motion of that giant wheel is also circular, we can say. Okay. Next state for periodic motion.
Ma'am, ma'am, pendulum of a clock.
Ma'am, swing. A swing.
Ma'am, a swing.
Swing. More.
Ma'am, the sewing needle of a stitching machine.
Sewing
Great.
machine.
Great. And can the motion of clock be also referred to as periodic motion? Motion of needle of clock.
The needle.
Yes, ma'am. Ma'am,
Hmm. Can
the
the
string of a guitar.
okay string of guitar, string of violin,
Ma'am,
string
a pendulum. Simple pendulum.
that I have already mentioned. Can the motion of the moon around the Earth and the Earth around the moon can be periodic?
Yes, ma'am. Correct.
Yes, ma'am.
Okay. I'm writing together motion of
Ma'am,
Earth.
rotation.
Pardon?
Ma'am, Earth rotation.
Earth's rotation, yeah, same thing. Okay, you can add that too. Okay, we have a lot examples of periodic motion. So I hope
Periodic.
I hope it's clear that rectilinear motion is like we do in the march past, riding a bicycle on a straight road, not taking any turn, or the race in athletics can be straight. Circular means a proper circular path. Okay, like needle of a clock, revolution of earth, revolution of moon, wheel, motion of wheel or motion of pan. Curvilinear, snake or snail, and periodic. So we can see, that many of the periodic motions are same as the in circular motion. Can a circular motion be periodic?
No, ma'am. No, ma'am.
Because
ma'am.
the revolution of Earth is circular and it is periodic as well. So this means circular motions can be periodic,
Yes, ma'am.
and vice versa is also true. Can periodic motion be also circular? Means all the periodic motion are circular or not?
No.
No.
Ma'am, like
No,
what did
ma'am.
you write in rectilinear
Can you
examples?
please
First,
justify? Can anyone justify?
Ma'am, because like the
Like
motion of a
all
pendulum
the
is
circular
not totally a
motions
circle.
are periodic, but
Ma'am,
Hmm.
like the motion of a pendulum is not totally circle. So it's only a periodic motion.
Okay. Fine. So, like motion of pendulum, motion of a girl sitting on a swing, they are periodic, but they are not circular, right? So, doesn't is it is not necessary that every circular motion will be periodic or every periodic motion will be circular. Sometimes circular and periodic motion may occur together because periodic means any type of motion that repeats itself in a certain span of time or in regular intervals of time, that is periodic. Fine. So swings, pendulums, and the needle of clock and the revolution of Earth or the moon, etc., are periodic. Right. Please note down these definitions with the examples quickly. Quickly note it down.
ma'am, what is oscillatory motion?
Oscillatory motion. Okay. Oscillatory motion in anything keeps on oscillating. It means kind of swing. That swing is oscillatory.
Ma'am, so it is basically periodic
Yeah.
motion.
Yes. Yes. Yes.
Ma'am, is there any difference between periodic and oscillatory motion?
You can say that periodic repeats itself after regular interval of time, but it is not necessary for oscillatory motion. Where this word oscillations is used for, uh, like it's quite a technical term.
Okay, ma'am.
Although this PPT will be uploaded on your,
Ma'am, can you give one
don't waste
example?
much time in writing, write only important points.
Ma'am, can you give one example for oscillatory motion?
Oscillatory motion. This pendulum is also example of oscillatory motion. Basically, you can just understand that periodic motion is not necessarily circular. If a girl is sitting on a swing, okay, and he's enjoying the swing, that is kind of straight because no curved path, no circular path followed. just repetition of to and fro motion of the swing on a straight path, right? So periodic can be periodic motion can be straight, can be circular, whereas oscillatory motion always means to and fro only. And periodic is supposed to repeat itself in regular interval of time, whereas this is not the case with oscillatory.
Ma'am, so like if it's to and fro, isn't like pendulum is an example of oscillatory?
Because see, if I say the motion of revolution of Earth around the sun, this is not to and fro, but this is periodic. Okay.
Yes, ma'am.
Whenever the motion of a swing is to and fro, it is periodic also, it is oscillatory also. But that revolution of Earth is not oscillatory because it is following circular path, but it is periodic because it is repeating itself.
Okay, ma'am.
So, ma'am, basically the motions which are moving to and fro and are repeating in a regular intervals of time is called periodic. And if the motion is only to and fro, it is oscillatory.
Yes, yes. Just write down for oscillatory the to and fro motion of an object about a fixed position is oscillatory. I'm telling, right? Please note it down. The to and fro motion of an object to and fro motion of an object about a fixed position is oscillatory motion. Be quick in noting down, please.
Ma'am, I completed.
Ma'am, just 1 minute.
Done, ma'am.
Ma'am, I'm writing.
Ma'am, what is written after strings of guitar?
Sorry, where? What are you asking?
In periodic examples, what is written after string of guitar?
Revolution of Earth or moon. Okay. Okay, I'm clearing the annotation. Fine. I hope all have written. Next topic is slow and fast motion. Okay. Now we are moving towards how to identify that which object is moving slow and which is moving fast. So basically, if one object covers a particular distance in lesser time, okay, that means we are telling that fixed distance in lesser time and another objects cover same distance in more time, then the first object is said to be moving slowly and second object is said to be moving faster. It means basically if we fix the distance, this is first object, this is second object. The first object takes less time, the second object takes more time. Then which of these is moving slow and which is fast?
Ma'am, the second object is moving slow.
And the first object is moving fast.
Okay. And in second case, if we fix up time and define on the basis of distance, that is, if time is fixed and first object is covering less distance, second object is covering more distance in the same span of time, then which of these is slow and which is fast?
And second one is faster and the first one is slow.
Second one is fast here and first one is slow. So on basis of this chart, we can understand that basically slow motion and fast motion means we are trying to define speed of object, isn't it?
Yes, ma'am.
Okay. Now for fast means something we want to be more. For fast, distance should be more. For higher value of the motion, for the speed, distance should be more. And from here we can see that for same large value of speed, time should be less. So it means speed is directly proportional to the distance. Like speed is in numerator on left hand side, distance is also in numerator on right hand side. So these are going directly proportional. If one quantity increases, the other also increase. If distance decreases, the speed also decreases. This is known as direct relationship, direct proportionality. Clear? Whereas with respect to time, if we defining with respect to time, we can see it is going opposite. For fast object, time should be lesser. For slow motion, time should be more. It is going inverse. Are you getting? So time comes here in the denominator. That is, if speed is a numerator, time is in denominator on other side. So this type of relation is known as inverse proportionality. Opposite. Is it clear?
Yes, ma'am.
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So you can draw simply these two tables, very simple just to understand. And on basis of these two, we have defined the formula for speed, which is equal to distance upon time. Very much clear. When two physical quantities are lying on the like same numerator on the either side of equality sign, then they are directly proportional to each other. And directly proportional means if one factor increases, other factor will increase. If first factor decreases, other factor will also decrease. Whereas if speed is in numerator, time is in denominator on either side of equal, that means they are going inverse relation. Means if time is more, that means speed is coming less. And if time is lesser, that means speed is more. Okay, so note down please. Only these two small tables and the formula for speed, that's it. Noted?
Yes,
Ma'am, so like basically when a particular object is covering a particular distance in less time, it is fast.
Hmm. Yes. Yes, correct. And for fixed span of time, if the object covers more distance, then it is said to be faster. And vice
Okay.
Should I clear it?
Ma'am, right.
Hmm.
And speed is indirectly proportional to time.
Yes.
And
this,
it is directly proportional to distance.
yes.
Okay.
I hope it is done. I'm clearing it out, okay?
Okay, ma'am.
If an object covers more distance in specific time interval than the other, then first object is said to be interested, which we have learned. So here comes the topic of speed. The distance covered by an object in unit time is called speed. Okay. The formula is this, and SI unit of distance is meter. Okay. Any idea about what is SI stand for? This was in grade 6. Motion and
System international or something.
international standard.
Ma'am, international system of unit.
Yeah, so these units for any physical quantity, whatever it is, like for distance it is meter, for time it is second, they are accepted worldwide. Because see, in earlier time, people used to measure distance by, some are measuring with the hand span, some are measuring, say by foot length, etc., by elbow distance. So means, how can we make this one? How should we communicate with each other? What is the exact unit? If everyone is speaking in his own language, we cannot share our thoughts and views, isn't it? So like, like simple language only, uh, this we have fixed up the units of physical quantities also, so as to keep it same and so as to interact, so as to communicate the values in single term. Otherwise, just generally, what are the other units of distance apart from meter? Any other unit?
Kilometer.
Mile.
Kilometer, millimeter.
Kilometer,
Centimeter and millimeter.
Mile is also there.
millimeter, and other, what you said?
Mile.
Voice is breaking, Devesh.
Centimeter.
Centimeter, okay.
Mile.
Miles, great.
Ma'am, decimeter.
Decimeter, good.
Meter.
We can generally put them in the
Kilometer, ma'am.
meter. Then next,
They write the rule or something.
Ma'am,
next
hectometer.
millimeter. Above, on top of meter comes decimeter. Is equal to how much?
Yes, ma'am. Decimeter.
Pardon?
Ma'am, kilometer.
Directly kilometer.
Hectometer.
Ma'am, hectometer.
Hectometer, okay.
Decameter.
Decimeter. Decameter.
Decameter.
Meter, okay. So kilometer is how much of meter? 1,000 meters.
1,000.
1,000, ma'am.
I can say hectometer. This is how much with respect to meter?
Ma'am, 100.
100 meter, right. Next is decameter.
Ma'am, 10.
10.
Meter, great. Comes decimeter. This is 1 by 10 meter. That is 1. Okay. Next,
Okay.
next comes
Ma'am, 0.01.
0.01 meter.
okay. And next we can write down is millimeter. Millimeter is how much?
And 0.001.
0.001.
Hmm. This was just general information, nothing else. Okay. So unit of distance, standard unit of distance is meter. Standard unit of time is second. So as per the formula, if we look at the formula, we can get distance meter, time second. So standard unit of speed becomes meter per second. Okay. Or it can be written as like this, or it can be written as this way. MS minus 1. Okay. And from this, you can, if suppose you are given with the value of distance and speed, you need to find out time, then formula for time would be distance upon speed. And similarly, if you are provided with speed and time, then formula for distance will be speed into time. Time equals distance upon speed. Whereas if distance is to be find out, then you can simply multiply speed and time. Okay, note this down quickly. The speed part. Are you noting down?
Yes.
Well, other units like distance, other units of time can be
Ma'am, minutes, hours,
Ma'am, minutes,
seconds.
seconds,
minute.
milliseconds, and microseconds.
So
Ma'am,
usually
hours,
in
hours.
in numericals, you will mainly find these three units: seconds, minute, or hour. Okay, and if in case suppose the question is asked to you, the speed is given in kilometer per hour, and you are supposed to convert in meter per second. How would you do that? Suppose the value is 5 kilometer per hour. Convert this into meter per second. How will you do that?
Ma'am, will multiply the kilometer, will convert kilometer into meter and hours into second.
Fine. So 1 kilometer I'm writing directly is 1000 meter, and R is in denominator. So 1 hour is how many seconds?
Ma'am, 1 hour equals to 3600 seconds.
Because 1 hour equals 60 minutes and each minute is 60 seconds. So basically 60 into 60, you get 3600 second. Okay.
Yes, ma'am.
By calculation, you can get the answer in meter per second. Fine. And it can be vice versa also. You will be given the value in meter per second. You have to convert in kilometer per hour. This can be inverse also. So be careful.
Okay, ma'am.
Noted? Okay. Convert one of the value here only. Convert 200 meter per second into kilometer per hour. Or sorry, let me write 20 meter per second. Just a second. Don't take 200, take 20 meter per second. This is the first question. This is the second question. Convert 20 meter per second into kilometer per hour now. And tell me both of their answers. Should I help for question second?
Ma'am,
Hmm.
20 meter. Should we take a decimal point?
Why decimal? Achha, wait, hold on. Let me solve for others if they are feeling difficulty. See, 20 with 20 meter is in numerator and meter to kilometer. If 1 kilometer is 1000 meter and we have to go inverse from a smaller to bigger unit, then we are supposed to divide it by 1000. Is it okay? This is for I'm converting meter into kilometer. Is it okay, everyone?
Yes, ma'am.
Fine. Next is
Ma'am,
R in
0.020.
just a second, please give me a minute. Second is in denominator. Now again, 1 hour equals 3600 seconds. So 1 second equals 1 by 3600 hour. Reverse. Whenever we go from a smaller to bigger unit, that usual normal conversion gets reversed 1 by reciprocal. Okay. So 3600 will be in numerator this time, and we have got second here. 7th class, if anyone feeling difficulty, please open. If you're not able to speak up, please share with me in the chat so that I can
So
explain
it will
it.
be 20 into 3.6.
Now please solve whatever answer you are getting. Very simple, 36 into 2.
Can you explain it again? Like I got like network issue.
Sorry, it should be R. 72 kilometer per hour is the value. Is it clear?
Ma'am, did you
Yes,
do
ma'am.
speed check?
Hmm?
Okay, ma'am, speed. You are correct.
I mean 720, right?
72, why 720? 72 only. Tell me the answer for the first part, the first question quickly. Please tell the answer for first question quickly.
Ma'am, I did not understand. Can you explain it? Like I was having
Ma'am,
some
how we
network
got
issue.
16 to 60?
Pardon?
Ma'am, how did we get 16 to 60?
Wait. Let me first clear my page, then I'll tell you. Although the time is over, but still I'll try to explain. Just give me a minute. Those who have not understood, please look here. Suppose you have to convert, okay, 1 hour. First, come from hour to the next smaller, that is minute. 1 hour is how many minutes? 60 minutes?
60.
Okay. Now leave this 60 as it is, and I'm writing minute as 1 minute. So doesn't make change. It is that simple as the earlier one. Okay. This 60 is as usual again. Now jump from minute to the next smaller unit, that is second. 1 minute is how many seconds?
60.
60 seconds.
60 seconds. So directly look at this to this tab means we have directly, I wrote this value 60 into 60. 1 hour equal this much second. Multiply, you get 3600 seconds. That's it. Clear now?
Yes, ma'am.
Everyone 7th class, is it clear to you?
Yes,
Ma'am,
ma'am.
60 minutes into 60 seconds.
Hmm. Okay, then I'll post the questions for homework. Okay, fine. Then we'll meet tomorrow. Please revise and try to do the questions so that you can connect further to the other topics.
Okay, ma'am.
Okay,
Bye,
bye
ma'am.
everyone.
Ma'am, 1 second is
Bye, ma'am.
equal
Thank you,
to
ma'am.
Okay, ma'am. Bye, ma'am.
how much hour like
Pardon? What are you asking only?
ma'am, like 1 hour is like 1 second is equal to how many hours? Like we'll use a decimal point, right?
Yeah, or you can do simply one thing. See, for every conversion, for any units conversion, if suppose 1 kilometer equals 1000 meter, for the same conversion, now not kilometer to meter, but to meter to kilometer, just do the reciprocal of the number. If it was 1000,
Okay, ma'am.
now if you move to meter to kilometer, 2000, multiply with 1 by 1000. That's simple. Is
Okay,
it okay?
ma'am. Thank you.
And
Yes,
similarly,
ma'am.
for 1 hour equal 3600 seconds. Okay, she left. Fine. Bye, Siddhant.